Welcome to the Ford Powertrain Fuel Injection and Air Metering System Update. This presentation is brought to you by the Ford Powertrain Operations Office to provide you with the most up-to-date information concerning the service of fuel injectors, idle air control valves, and throttle bodies used on the domestically produced NEO engines. There are several reasons for the program, the first being our goal of increased customer satisfaction by assuring that vehicles are fixed right the first time. The most effective way to accomplish accurate repairs is to assure that our technician body has the training and the information to accomplish this task. Preparation is the key, and after you watch the program, review the manual, and learn how to effectively use the accompanying job aids, you'll be better prepared to handle fuel system-related concerns. The second important reason for providing this program to you is to assure that the most current information and techniques are being used. Let's face it, EFI fuel systems have been in use since 1983. Many service procedures have been modified and remodified to allow for changes in technology and techniques. It's our intent to bring everyone up to date so that we'll all be working from the same knowledge base. The third and final primary reason is to reduce warranty returns. Now, this is a touchy subject for everyone involved in the area of service, but there's no sense in replacing a good component. First, it doesn't fix a concern, and second, it's a waste of time and money. This video and the accompanying material provide some sound information to help you make the correct repair the first time. You probably noticed that the accompanying materials for this program include a manual, chart, sticker, and poster. The poster can show at a glance the allowable service on Ford throttle bodies and idle air control valves. The sticker shows the recommended part numbers and applications where deposit-resistant injectors, commonly called DRIs, can be used to replace non-DRI injectors. The chart is used to show what vehicle and engine combinations use DRI injectors and which don't. This is important to know because DRI injectors are not meant to be cleaned. The manual contains the information presented in the video, along with more detailed information and descriptions. The manual and job aids are discussed in more detail later in this presentation. Another important factor that concerns this program is where does it all fit into the diagnostic routines developed by Ford Motor Company? Well, the answer is right in the middle. This program is not meant to replace the Powertrain Control Emission Diagnosis Manual, the Service Bay Diagnostic System, OASIS, or Technical Service Bulletins. Rather, this program is meant to explain the hows and whys of diagnosis and service, particularly as it applies to fuel injectors, idle air control valves, and throttle bodies. The program is divided into four basic parts. They are basic fuel, fuel delivery, fuel injectors, and throttle bodies and idle air control valves. So without further ado, let's get started. The first segment of this program begins with a discussion of fuel and its importance to a properly operating automobile. Recent changes from the Environmental Protection Agency and other government units have caused oil companies to change the mix of the fuels they provide to consumers. These changes include reduced volatility fuels to lower evaporative emissions and oxygenated fuel which contain alcohol or an additive known as methyl tertiary butyl ether, commonly called MTBE. The primary point to understand about fuel is that Ford and Lincoln Mercury products are designed to run on commercially available fuel which fit into specifications provided to Ford from the oil companies. Conditions where fuel has been tampered with, such as by fuel suppliers adding extra alcohol, or situations where the gas is just plain bad, can cause drivability malfunctions that could be blamed on fuel system components. So what can we do about bad fuel? Well, about all we can do in addition to changing the fuel is to identify the problem to our customer and recommend they change their fuel source. We can also point out the importance of fuel to them by showing them the section of the owner's manual concerning the use of recommended fuels. It's essential that customers who have run into bad fuel understand that it is not the car's fault. It is an owner's responsibility to purchase a quality fuel to power their car. Conditions that indicate poor fuel are typically associated with poor drivability and hard or no starts when the engine cranks normally. We do have the capability to check fuel at the dealership level using the Rotunda Gas Check Kit. This particular tool allows technicians to look at 3 areas of concern. First, using the paste and probe included in the kit, we can check for water. Second, using the graduated container, we can check for percentage of alcohol in the fuel. And third, using the pressure cup and gauge, we can check the volatility of the fuel. What this kit can do is provide a diagnostic base that assures that the fuel is of reasonable quality and is not a probable cause of a drivability condition. A final point I want to note about the kit is that it contains a detailed list of instructions concerning how to make all the checks we've mentioned here. Before we can move on to discussing the primary areas of this program, mainly fuel injectors, throttle bodies, and IAC valves, it's important to assure that we're all familiar with the fuel delivery components. This is absolutely essential to accurate diagnosis because a failure or malfunction may be mistaken for the fuel injectors, throttle body, or IAC, causing them to be unnecessarily replaced. The manual that accompanies this video contains extensive information concerning fuel system operation. Please review this information to assure that you're up to date on terminology, components, and diagnostic considerations. Another area covered in the manual is the importance of proper fuel pressure to engine operation. Let's spend just a moment on fuel pressure. There are 2 methods of checking fuel pressure. First, we have the basic fuel pressure test gauge and the procedures published in the Powertrain Control Emissions Diagnosis Manual. These procedures must be followed exactly to assure the integrity of the fuel system components. The second method of checking fuel pressure is the customer flight recorder of the service bay diagnostic system. Using this device, we can check fuel pressure during vehicle operation. In some cases, this type of check is absolutely essential. Malfunctions or poor drivability concerns may not show up on a constant basis. Checking for fuel pressure or leakage conditions during operation make this type of test equipment essential to accurate diagnosis, and it allows you to check other component functions at the same time. One other check that has something to do with fuel pressure is accomplished with the Rotunda Fuel Pump and Pressure Regulator Testing Adapter. This tool is used in conjunction with the Rotunda Fuel Injector Tester. Its purpose is to isolate leakage conditions in specific parts of the fuel system. This allows individual leakage checks of the fuel pump check valve, fuel injectors, and the pressure regulator. Since the introduction of multi-port fuel injection in 1983, there have been a variety of different fuel injectors used in Ford vehicles. In this segment, we'll be concentrating on the injectors used in multi-port fuel injection systems. These fuel injectors are all quite similar in appearance and basic operation. In fact, probably the most noticeable difference is in the tip. Older style injectors have a pintle that's exposed to the combustion chamber. Newer style injectors have a director plate exposed to the combustion chamber, or have a larger pintle that is not susceptible to clogging. In a typical fuel injector, an electrical signal activates the solenoid, causing the pintle to move off its seat, allowing fuel to spray into the combustion chamber. Because the injector tip is fixed and the fuel supply regulated, the fuel flow to the engine is controlled by how long the solenoid in the injector is energized. The amount of time the injectors are commanded to deliver fuel for a single injection event is referred to as the pulse width. Proper atomization of the fuel, that's the mixing of the air and fuel, is determined by the contour of the pintle of the injector, or the design of the director plate. These parts in fact, all of the parts, are very precisely manufactured to assure that fuel sprays out in a controlled pattern that promotes complete combustion. That means keep fuel injectors clean if they must be removed and handled. Injectors are very precise, but tough, reliable, and well-tested components. They typically do not fail. In fact, the majority of the fuel injectors returned under warranty have nothing wrong with them. So let's not get into the habit of just replacing injectors without proving there's a malfunction. Let's only replace them when there's a specific proven problem and you're sure the injector's the cause. Part of our upcoming discussion is how to properly test and check fuel injectors to verify a malfunction. But before getting into that, we need to look at how fuel injectors have evolved and what type of condition would be evident with a failed fuel injector. Probably the most dramatic change in fuel injectors from a service point of view is the move to deposit-resistant injectors, commonly referred to as DRI. Earlier injectors, known as non-DRI, were subject to a condition where deposits would collect on the injector tip and disrupt the flow of fuel. The typical cause of these deposits is that fuel would bake onto the injector tip when the engine was shut off. You see, with the old-style pintle injectors, there's always a little droplet of fuel left over after an injection. Once the engine is shut off, that droplet bakes onto the tip. If high-quality, high-detergent fuels were used, these deposits would be theoretically minimized and less likely formed on the metering surface. Unfortunately, not everyone uses high-quality fuels, so the deposits could build up until the flow was disrupted. The typical result would be a lean fuel condition during acceleration, cold starts, and under load, or a rough idle. The reason for the problem under these conditions is that the deposits would prevent sufficient fuel from being provided to the combustion chamber. Rough idle would be caused because the deposits disrupt the proper fuel flow to the individual cylinders. When conditions like this occur, the original recommended repair was to clean the fuel injectors using the Rotunda Fuel Injector Cleaner or Motorcraft Aerosol Cleaner. This usually would correct the condition, but was not a permanent fix. The incidence of injector deposits and the need for cleaning were reduced significantly by the introduction of deposit-resistant injectors. Some of the first DRIs were actually deposit-tolerant injectors. They were changed so that the majority of the fuel metering function was moved to within the injector and handled upstream of the injector tip. As you can see, the opening in the tip is considerably larger than on non-DRI injectors, but the pintle is still exposed to the combustion chamber. The larger tip area allowed deposits to form without affecting the operation of the injector. Other DRI injectors were designed to remove the pintle assembly and add a director metering plate. This design prevents baking fuel onto the injector tip and virtually eliminates deposits as a cause of drivability concerns. Their introduction also eliminated injector cleaning as a recommended repair because deposits just don't normally form on this type of injector. DRI injectors were phased into production beginning in 1990. They did not appear on all vehicles at the same time. You've been provided with a job aid indicating the introduction of these injectors into individual Ford and Lincoln Mercury vehicles between 1990 and 1994. DRI injectors work very well, and they are a significant improvement over the prior non-DRI injectors. Remember that DRI injectors must not be cleaned. There are three primary reasons for this. First, the cleaning of these injectors will not improve or detract from their performance. That means it's a waste of time. Second, the warranty system no longer allows payment for this type of repair. Third, and most important, cleaning will not correct a customer's concern. So instead of thinking about cleaning injectors to make a repair, look more closely at other causes, especially fuel quality. So you may ask, how do you tell the difference between the DRI and non-DRI fuel injectors used in NAO engines? Well, you can use the job aid we've provided, and you can take a look at the fuel injectors. The part number on non-DRI injectors always begins with an E. The part number on DRI injectors always starts with an F, indicating a later design part. This is the best and quickest way to determine if an injector is DRI or non-DRI. Remember, this applies only to domestically produced NAO engines. Also, there are some other methods of identifying injectors, such as by the injector body color. These are discussed in the manual that accompanies this program. An innovation that's occurring in 1994 is the new generation DRI fuel injector. This new injector combines the same deposit resistance feature with a new lightweight design that's smaller and thinner than the prior fuel injectors. This makes the injector easier to fit into specific engine packages. This new design injector includes stainless steel components that are more resistant to corrosion and increase the operating life. Also, the injector has a dry coil, meaning that the coil has no contact with the fuel. So if a corrosive fuel is used, such as with a high percentage of methanol, it will not damage the injector coil. The new injector is used in 1994 Thunderbird and Cougar models with the 4.6-liter engine and will be phased into production on other vehicles and engines throughout the 1990s. We also have another style fuel injector, the bottom feed injector. This injector will be used in the NAO 2.5-liter V6 applications. The bottom feed injector is similar in appearance to the TBI low-pressure fuel injector. The bottom feed injector is mounted into the fuel rail so that fuel surrounds the base. A point to note about the bottom feed injector is that if service is required, the entire fuel rail must be removed. Also, if a bottom feed injector is removed, replace the O-rings. In the bottom feed application, the O-ring functions as a fuel seal for the cylinder. If the O-ring leaks, excess fuel is pumped directly into the engine, which could cause engine damage due to hydraulic lock. To assure seal integrity, always check fuel pressure after assembling the fuel rail onto the engine and before restarting after the repair. The next topic to discuss concerning fuel injectors is diagnosis and service. I stated earlier that the majority of fuel injectors returned under warranty were found to have no problem. But the good news is, the overall number of good fuel injectors returned has actually decreased since DRI fuel injectors came into use. One of the goals of this program is to further reduce the percentage of good fuel injectors coming back. We need to do this for two reasons. The first is that if a good fuel injector is returned, it means that the customer's concern may not have been corrected. We need to make sure that a repair is made and the customer is satisfied. The second is cost. There's a lot of money being spent to replace good parts. Now, as far as diagnosis and service are concerned, the lean fuel conditions that were common with non-DRI injectors are virtually eliminated. That means that full sets of injectors will rarely ever be the cause of a poor drivability condition. If you're faced with a situation where you think all the injectors are malfunctioning, check the fuel. If there's an injector malfunction, it will typically be isolated to one or two cylinders. It is extremely rare that an entire set of fuel injectors will go bad. So don't replace a full set unless testing and inspection show they all failed. Because a fuel injector malfunction is typically limited to one or two cylinders, the basic symptom would be rough running or a miss at all speeds. As you're probably aware, rough running or a miss could be caused by a variety of components or systems. Because of this, it is absolutely essential that the procedures found in the Powertrain Control Emissions Diagnosis Manual be followed to isolate a condition to a particular cause. Also, it helps to know of checks that can be used to isolate a potential failed injector. Here's a list of the 10 checks we'll discuss. The first is cylinder drop. This check can be performed with a scope by disconnecting a spark plug wire or by disconnecting a fuel injector. The premise is to look for a cylinder that, when dropped, does not cause an RPM decrease. Once the bad cylinder is located, further checks can be performed to see if the cause is the fuel injector. Cylinder drop may also be referred to as cylinder balance. A cylinder balance check can be performed on SFI engines using a Superstar 2 tester, New Generation Star, or with SBDS. Next is spark plug condition, which is a visual check. If the spark plug is wet or fouled, it may be an indication that the injector is stuck open, partially stuck open, or leaking. If the spark plug is white, it indicates a lean condition, possibly caused by the injector being stuck closed. If a lean or rich condition is indicated, don't just replace the injector. Check the injector operation with the Rotunda fuel injector tester to see if it works. Also, check the injector harness to assure that there is a good connection. If you find a situation where you don't think the injector is operating, you can perform the fourth check, which is injector sound. Just listen to the injector using a long screwdriver, with a mechanic's stethoscope, or chassis ear. There should be a distinct clicking sound as the solenoid within the injector turns on and off. Listen. If you encounter a condition where you don't hear the injector, don't immediately replace it. Instead, perform check number 5, harness integrity. Do this to make sure that you've got a good connection at the injector. A method of checking harness integrity is to use a light that plugs into the individual connectors on the injector harness. Whenever a signal to turn on the injector is provided, the light turns on. When the injector is turned off, the light goes off. It's simple, but it works. Another check that can easily be made is number 6, injector resistance. Each injector should be within a particular resistance range. This range is not the same on all injectors, so be sure to check it against the appropriate chart in the Powertrain Control Emissions Diagnosis Service Manual. Injectors that are found to be out of range should be replaced, as it indicates a potential problem with the solenoid coil in the injector. The next check that can be made is the tailpipe inspection. If there's a rich condition, such as could be caused by a stuck or partially stuck fuel injector, check for smoke coming from the tailpipe. This may also be accompanied by a fuel smell, dripping fuel from the tailpipe, and high temperatures coming from the exhaust catalyst. You may also notice the fuel smell when performing check number 8, the oil inspection. The odor of fuel can be caused by a stuck open injector. What happens is that raw fuel goes past the rings into the crankcase, contaminating the oil. If an injector is suspected of having a problem, one of the best checks that can be made is the operational check with the Rotunda fuel injector tester. This tool is designed to check fuel injectors on vehicle or individual injectors out of the engine. Before replacing an injector, always bench test it to assure it has actually failed. The final check we'll discuss is flow testing with the SBDS machine. Flow testing injectors can pinpoint a malfunction within a set of injectors. What the SBDS does is compare the operation of all the injectors and points out if 1 or 2 injectors are performing improperly. A lean fuel condition, where all the injectors are involved, might be difficult to see with this check because SBDS looks for individual differences. But because of the use of DRI injectors, lean fuel conditions involving all the injectors are becoming quite rare. It's the 1 or 2 injector malfunctions that are more common, and this check allows you to easily pick out the problem injector. By using these individual checks, either by themselves or in conjunction, it's actually reasonably easy to pick out an injector malfunction and also to verify if a particular symptom or condition is not the fault of the injectors. Please use them in your diagnosis and make sure that an injector is actually malfunctioning before you replace it. The last point to discuss on fuel injectors is the replacement of non-DRI injectors with DRIs. You received with this program a sticker that contains the replacement part numbers to allow you to install a set of DRI injectors in the place of non-DRIs. Customers should be informed of this option to eliminate the need for periodic injector cleanings. You can place this sticker on your toolbox or other convenient location as a quick reference for the recommended DRI injector. The throttle body assembly is one of the primary components of the air intake system. Its primary purpose is to control the amount of air entering the engine in response to the driver's input through the accelerator pedal. Typical throttle bodies may have one or two throttle plates. The idle air control valve, typically called the IAC, is responsible for providing a varying amount of air to control idle speed. Unlike the throttle body, which has a throttle position controlled by the driver, the IAC valve is controlled completely by the Powertrain Control Module, or PCM. The typical mounting point for the idle air control valve is on the throttle body, although a few applications have them mounted on the intake manifold. During operation, the IAC valve meters airflow, bypassing the closed throttle plate. It takes air from in front of the throttle plate, then meters the air into the intake manifold behind the throttle plate. The IAC valve performs the following functions: cold engine fast idle, no touch start, dash pot functions, over temperature idle boost, engine idle load compensation, including that for air conditioning and power steering boost, engine break-in compensation, and altitude compensation. The basic movement of the pintle within the IAC is what meters the amount of airflow. When commanded by a duty cycle from the PCM to provide an increased amount of airflow, the pintle position is changed to allow more air to go through the valve. If the PCM determines that there is too much air being provided, the pintle is moved closer to the seat, reducing the airflow. You must understand that the IAC is not the only supply of airflow at idle. Throttle bodies either have an orifice drilled into the throttle plate to allow airflow when at idle, or there is a passage drilled through the throttle body housing, which allows a fixed amount of airflow. The IAC simply supplies a metered airflow that allows the PCM to tailor the idle speed to match the operating condition. It's a very important component as far as the vehicle owner is concerned, because poor idle conditions are highly noticeable. Now that you've seen the basic operating characteristics of the IAC valve, let's take a look at the three IAC valves that are currently used on Ford and Lincoln Mercury vehicles. The first is the Hitachi IAC valve that is cleanable. You can identify this valve by its silver housing. Remember, this valve can be cleaned if necessary. The second valve is also manufactured by Hitachi and is silver and black in color. But the main identifier is the vent filter assembly on its body. This valve cannot be cleaned, and if it is determined to be defective, it is serviced by replacing it. The third valve is manufactured by Nippon Denso and is identified by a black plastic housing. This IAC valve cannot be cleaned and is also serviced, if necessary, by replacement. Now, let's take a closer look at the throttle body. Throttle bodies vary in design and may be equipped with a variety of features. The word may is stressed because these features are not found on all applications. The features include a throttle plate stop, which maintains a minimum throttle plate position, an air trim adjustment needle, which provides an adjustment point for an airflow passage in the throttle body. Typically, this adjustment is made at the factory, and then a rubber plug is placed over the adjustment screw. This adjustment should not be tampered with unless called for by a specific procedure from a service manual or TSB. Next is a preset stop that determines wide open throttle position, a throttle position sensor to provide the PCM with a throttle position input. Also, there may be taps for vacuum, PCV air source, PCV air return, evaporative emission canister purge, and engine coolant passages. The final feature to mention is a sealant coating covering portions of the throttle plate and throttle bore. The purpose of this coating is to make the throttle body airflow tolerant to intake sludge accumulation. Throttle bodies with this coating must not be cleaned and have a decal placed on the throttle body advising not to clean. This coating is used on all 1993 and newer Neo throttle bodies. Throttle bodies produced prior to the sludge-tolerant design level had required periodic cleaning to remove sludge buildup, as it would hamper airflow and cause idle concerns. A service kit, to be discussed later, has since been released that eliminates the need for cleaning on the majority of these pre-sludge tolerant throttle bodies. Now you may ask, why would sludge build up in the throttle body? Well, the reason is due to the EGR and PCV gases that are routed through the intake manifold near the throttle body. Sludge can build up over time and cause idle concerns. The typical buildup area is the underside of the throttle plate and the bore beneath it. What the coating on the sludge-tolerant throttle body does is provide a factory-applied pre-sludge surface in the typical area where sludge buildup occurs. This coating is applied during the manufacture of the throttle body and is baked onto the surface. The primary advantages of this coating are that it makes the need of an idle speed adjustment highly unlikely, and it makes cleaning unnecessary. That means cleaning is not allowed. Sludge-tolerant throttle bodies have air passages which are not subject to sludge buildup. A portion of the air required for idle goes through these passages, and the remaining portion of the air required to control idle speed goes through the IAC valve. Now, if this coating is removed, it destroys the idle airflow setting of the throttle body by allowing excess air past the throttle plate. If someone tries to reduce the airflow by adjusting the throttle stop screw, it may cause binding of the throttle plate in the closed position. That's why it's essential that sludge-tolerant throttle bodies are not cleaned and the coating not disturbed. You know what it all boils down to is that on the new throttle bodies, there's nothing that needs to be done. The addition of the coating on the lower throttle body and throttle plate have eliminated most adjustments and all required cleaning. The next part of our discussion involves the recommended diagnostic techniques. As I mentioned at the start of this program, we do not mean to replace the information provided by the Powertrain Control Emissions Diagnosis Service Manual. We want to provide an enhanced explanation. In this service manual, there are diagnostic routines developed for specific symptoms. These should be followed. But what we do want to do with this program is make every viewer aware of how to diagnose conditions that could be blamed on the throttle body or IAC valve. In the manual that accompanies this program is a trouble tree that can direct you through the troubleshooting process that can assist in correcting a condition that could be related to a throttle body or IAC valve. We'll use this trouble tree to assist in going through the rest of this section to demonstrate its use. But before we do that, let's review the 6 primary reasons why a throttle body or IAC can malfunction. First, it could be caused by a previous misadjustment of the throttle body. Second, it could be caused by the buildup of sludge or an oil film on the throttle bore and throttle plates. This applies only to the pre-sludge tolerant throttle bodies. Third, there could be a buildup of sludge deposits or an oil film in the IAC valve. This applies only to the cleanable IAC valve. Fourth, someone could have erroneously cleaned the coating from a sludge-tolerant throttle body. Fifth, someone could have erroneously cleaned a non-sludge-tolerant throttle body that had been previously updated with an idle adjustment service kit. Sixth, there could be a stick, bind, or grab symptom in the accelerator and throttle linkage system. As you can see, there's not a whole lot that can go wrong with the throttle body and IAC valve. Now, let's go through the trouble tree that's been developed to help you determine if service is required on the throttle body. The first step is to determine if the drivability condition is related to the throttle body. To answer this, you have to know what conditions can be related to the throttle body and what conditions are not. The manual that accompanies this program contains a list of these conditions. We won't review all the symptoms here, but a good base rule to follow is that throttle body and IAC conditions are typically related to idle. Conditions that occur off idle are more likely than not to involve components or systems other than the throttle body and IAC. The one non-throttle body related symptom that must be discussed is poor fuel economy. This is one of the primary reasons given for servicing the throttle body on warranty forms. But poor fuel economy has nothing to do with the throttle body. So what I want to bring up here is, don't replace or service the throttle body because of a poor fuel economy complaint. Now, let's get back to the trouble tree. If the condition is possibly related to the throttle body, we can proceed. If it's not related to the throttle body, refer to the symptom list contained in the Powertrain Control Emission Diagnosis Service Manual. The next step is to determine if there are any diagnostic trouble codes present. If there are DTCs present, they have to be corrected before proceeding. The reason for this is that DTCs could be indications of the cause of the condition. If you correct the DTCs, maybe you'll repair the condition that caused the owner complaint. Once the DTCs are corrected, check to see if the throttle body symptoms persist. If the answer is no, then the vehicle can be returned to the customer. If the answer is yes, then verify that the related systems are functioning normally. To do this, refer to the pinpoint charts that are contained in the manual that accompanies this program. Until 1994, pinpoint test charts for throttle bodies and IAC valves have not been available. The charts contained in the manual accompanying this program are meant to be used for all prior model year throttle bodies and IAC valves. Pinpoint test charts allow you to follow a logical approach and determine whether a throttle body or IAC valve is the cause of a poor drivability condition. What I want to do now is review the 12 major checks made in the throttle body and IAC pinpoint tests, and explain how a malfunction with any of them could be mistaken for a symptom caused by the throttle body or IAC. Let's start with the accelerator cable. This component must move freely through its entire travel. If the accelerator cable cannot return fully or returns too slowly, it may be mistaken for a malfunctioning throttle body or IAC valve. The speed control system can also cause symptoms that appear to be throttle body or IAC related. Check the cable going from the speed control system to the throttle body. If it is binding, it could prevent the throttle from returning to the throttle stop. Next is sticking, binding, or grabbing of the throttle mechanism on the throttle body. Check the entire movement of the throttle lever. This check should be performed both with the engine off and at idle, since the presence of manifold vacuum at idle can make a sticking concern more obvious. If there is sticking, binding, or grabbing, the throttle body will have to be replaced in most cases. A point to note is that this condition is often caused by someone mistakenly adjusting the throttle return screw setting. While you're at the throttle return screw, make sure the throttle linkage lever arm contacts the screw in the closed throttle position. If they are not in contact, it could create a high-low idle speed symptom or cause a stick-bind-grab condition. Also on the throttle body is the throttle position sensor. Incorrect readings from the throttle position sensor can cause rough or low idle conditions because the PCM cannot accurately determine fuel requirements or the proper duty cycle for the IAC valve. Usually, an improper reading will set a diagnostic trouble code, but there have been cases where a noisy signal from the TP sensor remains within operating parameters. Such a condition could easily be found using the SBDS machine. Our sixth check is of the air filter. It must be checked because an extremely dirty air filter could prevent sufficient airflow to maintain idle speed. The PCV system could also be a cause because a clog will affect the amount of fresh air coming to the engine, resulting in a low idle. Also, the PCV valve must be correct for the application because the wrong valve could allow too much or too little air into the engine. The eighth area of concern is the EGR system. You must assure the EGR system is functioning normally. An EGR malfunction could cause an exhaust leak into the engine at idle, resulting in a rough idle that could be blamed on the throttle body or IAC. In fact, the exhaust system itself could cause symptoms that may be mistaken for the throttle body. A clogged exhaust system will prevent proper engine operation and affect idle quality, acceleration, and possibly cause an idle stumble symptom when returning to idle. Another system malfunction that could be related to the throttle body is the engine cooling system. It's necessary to verify the coolant temperature because if the coolant does not reach operating temperature, it will cause the PCM to keep the engine at high idle. The same could happen if there were an improper signal from the ECT sensor, but that would usually generate a diagnostic trouble code. If the coolant doesn't reach operating temperature, it's typically going to be caused by a sticking thermostat. Another system to consider is fuel delivery. If there's insufficient fuel pressure, it could cause a rough idle that could easily be blamed on the throttle body or IAC. The 12th and last check to discuss are vacuum leaks. If there's a vacuum leak, it negates the function of the IAC valve because there's an uncontrolled source of air into the engine. Remember, the IAC is what fine-tunes the amount of air going into the engine. So always make sure there's no vacuum leaks before suspecting the throttle body or IAC. All of the checks we just went over are included in the pinpoint tests and are provided in the order you should be making them. Now, let's go back to the trouble tree. If the condition has been corrected by performing the steps in the pinpoint tests, the vehicle can be returned to the customer. But if you've determined that more service is required on the throttle body, you should refer to the throttle body service charts located at the back of the manual provided with this video, or the poster that we've provided. The charts and poster contain all of the allowable procedures that can be performed on the throttle bodies and IAC valves used in past model and current Ford and Lincoln Mercury vehicles. As the trouble tree shows, there are several variables that can affect what can and cannot be performed on specific throttle bodies and IAC valves. Let's take a look at some of these variables. The primary variable concerns non-sludge tolerant throttle bodies. Most of these throttle bodies can have the Idle Adjust service kit installed. A full list of applicable vehicle and engine combinations that can use this kit is provided in the manual accompanying this program. Also, there is a full detailed description of the engine symptoms that would indicate the kit is needed, along with the installation procedures in TSB 91-25-7. With this kit installed, there is a path that is not affected by engine sludge, allowing a consistent flow of idle air, eliminating the need for periodic cleanings. When installing this kit, follow the instruction sheet that's provided and perform all steps as indicated. Failure to follow the required steps can result in poor drivability conditions. If a throttle body is already equipped with the kit, cleaning of the throttle body is not allowed. See TSB 91-25-7 for adjustment procedures. Also remember that it should not be necessary to replace a kit once it's installed. It's a one-time fix. If the kit was properly adjusted during installation, adjustment of the idle speed should not be required. Refer to the idle adjustment procedures in the TSB if idle speed needs to be verified. The next factor to consider is whether an IAC valve is cleanable or non-cleanable. Cleanable IAC valves are found on non-sludge tolerant and sludge tolerant throttle bodies. The chart that's provided identifies those vehicles on which cleaning can be performed. For the correct cleaning procedure, refer to the TSB. Finally, some throttle bodies are adjustable. This procedure is not the same on all throttle bodies. For non-sludge tolerant throttle bodies that need the service kit, refer to the TSB for the recommended idle adjustment procedures. Not volume H, or the Engine Emissions Diagnosis Service Manual for the vehicle involved. For sludge-tolerant throttle bodies where the service kit is not applicable, refer to the appropriate year Powertrain Control Emissions Diagnosis Service Manual for the recommended step-by-step procedures. By referring to these sources, you should be able to complete the trouble tree and make the repair on the throttle body or IAC valve. As we've demonstrated here, following the trouble tree and the pinpoint tests can be a real benefit to diagnosing conditions related to the throttle body and IAC. We highly recommend that you make them a part of your own diagnostic technique. Well, that completes the Ford Powertrain Fuel Injection and Air Metering System update. Hopefully, the information we've provided in this program will be a big help to you in diagnosing fuel system concerns and fixing our customers' vehicles right the first time. Thanks for joining us.